The National Electrical Code, or NEC, does not dictate a specific orientation for the equipment grounding, or, for example, lug on an electrical receptacle. This means that the code itself does not state whether the ground lug should be positioned at the top, bottom, left, or right when the receptacle is installed. However, while there's no explicit requirement in the NEC, there are common practices and guidelines that electricians often follow. One prevalent practice is to orient the equipment grounding lug at the top of the receptacle. There are a few reasons why this has become a common, though not mandated, approach. Firstly, it provides a degree of consistency in installations. When electricians consistently orient the ground lug in the same way, it can make troubleshooting and future work on the electrical system easier. Anyone examining the wiring will have a reasonable expectation of where to find the ground connection. Secondly, the equipment grounding conductor, which is the wire connected to the ground lug, is often routed to the top of the electrical box during installation. This is because the cable or conduit entering the box typically has the ground wire positioned in such a way that it naturally reaches the top of the receptacle opening. By placing the ground lug at the top, the connection can be made with a minimum of bending and manipulation of the wire. Thirdly, some believe that having the ground connection at the top may offer a slight safety advantage. In the event that a metal object falls onto the receptacle, it is theorized that it is more likely to contact the grounded portion first if it's located at the top, potentially tripping the circuit breaker more quickly and reducing the risk of electrical shock. Another common guideline suggests orienting the equipment grounding lug to the right of the neutral lug. This practice is often related to the standard color coding of electrical wires in North America, where the neutral conductor is white and the hot conductor is typically black. The idea behind this orientation is that the neutral wire, connected to the neutral lug, is usually routed to the left of the hot wire within the electrical box. Placing the ground lug to the right of the neutral lug helps to maintain a consistent arrangement of the wiring, with the ground wire positioned to the right of the neutral wire. However, it's crucial to understand that these are just guidelines and common practices. The NEC primary focus is on ensuring that the electrical system is safe and functions correctly, not on dictating the specific orientation of components as long as they meet safety standards. As long as the equipment grounding lug is properly connected to the equipment grounding conductor and the receptacle is installed in accordance with all applicable NEC requirements, the orientation of the lug is not a code violation. The NEC addresses the proper wiring and grounding of receptacles in several sections. Section 250 covers grounding and bonding in general, and it outlines the requirements for connecting the equipment grounding conductor to the grounding terminals of receptacles. Section 406.4 covers the installation of receptacles, and it includes requirements for grounding, tamper resistance, and other safety features. Section 314 covers outlet boxes, and it includes requirements for box fill, conductor bending space, and support. These sections, taken together, ensure that receptacles are installed safely and effectively, regardless of the specific orientation of the equipment grounding lug. When installing receptacles, electricians must also consider local codes and regulations which may have additional requirements or restrictions beyond those outlined in the NEC. Some jurisdictions may have adopted specific guidelines or interpretations regarding the orientation of receptacle components. It's always best to consult with a local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes. It is crucial to stress the importance of proper grounding in electrical systems. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit in the event of a ground fault. This protects people from electrical shock and reduces the risk of fire. To ensure proper grounding, the equipment grounding conductor must be properly sized and connected to all metal parts of the electrical system, including receptacle boxes, conduit, and equipment enclosures. The equipment grounding conductor must also be connected to the building's grounding electrode system, which typically consists of a ground rod, ground plate, or underground metallic water pipe. The NEC provides detailed requirements for grounding electrode systems in Section 250. In addition to proper grounding, it's also essential to use the correct type of receptacle for the application. For example, in damp or wet locations such as bathrooms and kitchens, ground fault circuit interrupter or GFCI receptacles are required to protect against electrical shock. GFCI receptacles detect ground faults and quickly trip the circuit, interrupting the flow of electricity and preventing injury. Tamper-resistant receptacles, or TRRs, are also required in dwelling units to protect children from inserting objects into the receptacle slots. TRR have internal shutters that prevent objects from being inserted unless both prongs of a plug are inserted simultaneously. These safety features, along with proper grounding, help to ensure that electrical systems are safe for everyone. In summary, while the NEC does not specify the orientation of the equipment grounding lug on a receptacle, common practices include placing it at the top or to the right of the neutral lug. These practices are based on factors such as consistency, wire routing, and perceived safety advantages. However, the primary focus should always be on ensuring that the receptacle is properly grounded and installed in accordance with all applicable NEC requirements and local codes. Proper grounding is essential for electrical safety, and it helps to protect people from electrical shock and reduce the risk of fire. Always consult with a qualified electrician for any electrical work to ensure compliance with all applicable codes and safety standards. Remember to always energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, call a qualified electrician. Electricity can be dangerous, and it's always best to err on the side of caution. Knowledge of the NEC is crucial for electrical safety. It is updated every 3 years. It's important to stay up to date on the latest changes to the code to ensure that your electrical work is safe and compliant. The NEC is a complex document, but it's essential for anyone working with electricity to understand its requirements. Consider taking a course on the NEC or consulting with a qualified electrician to learn more about the code. Electrical safety is everyone's responsibility. By following the NEC and using safe work practices, we can all help to prevent electrical accidents and injuries. The purpose of the grounding system is to provide a low impedance path for fault current to return to the source. This allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and de-energize the circuit in the event of a ground fault. Without a proper grounding system, fault current could flow through unintended paths, such as a person's body, causing electrical shock or even death. The grounding system also helps to stabilize voltage during normal operation. By providing a reference point for voltage, the grounding system helps to prevent voltage fluctuations and ensure that equipment operates correctly. The grounding system is typically connected to the earth through a grounding electrode system. The grounding electrode system consists of one or more grounding electrodes such as ground rods, ground plates, or underground metallic water pipes that are buried in the earth. The grounding electrodes provide a low resistance connection to the earth, which helps to dissipate fault current and stabilize voltage. The NEC specifies the requirements for grounding electrode systems in section 250. The NEC also requires that all metal parts of the electrical system be bonded together. Bonding is the process of connecting all metal parts of the electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same electrical potential, which helps to prevent electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that are used to connect metal parts together. The NEC specifies the requirements for bonding in section 250. Proper grounding and bonding are essential for electrical safety. They help to protect people from electrical shock and reduce the risk of fire. Always consult with a qualified electrician for any electrical work to ensure that the grounding and bonding systems are installed correctly. Remember to always energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, call a qualified electrician. Electricity can be dangerous, and it's always best to err on the side of caution. The National Electrical Code also outlines specific requirements for the size of grounding conductors. The size of the grounding conductor depends on the size of the overcurrent protection device protecting the circuit. For instance, NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors for various circuit sizes. Ensuring the correct size of the grounding conductor is crucial, because an undersized grounding conductor may not be able to safely carry the fault current back to the source, potentially leading to overheating and posing a fire risk. Furthermore, the NEC addresses the proper installation of ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs. GFCIs are required in locations where there is a higher risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. RFCIs are designed to protect against arc faults, which are a common cause of electrical fires. These devices provide an extra layer of protection against electrical hazards. In addition to the technical requirements, the NEC also emphasizes the importance of proper workmanship. Electrical installation should be performed in a neat and workmanlike manner, with all connections made securely and all wires properly supported. Sloppy or careless work can lead to safety hazards and code violations. Electrical inspections play a vital role in ensuring compliance with the NEC. Electrical inspectors review electrical installations to verify that they meet the requirements of the code. They can identify potential safety hazards and ensure that the electrical system is installed correctly. The NEC is not intended to be a design manual. It provides minimum safety standards for electrical installations. Electrical engineers and designers are responsible for designing electrical systems that meet the specific needs of the application while also complying with the NEC. The NEC is a living document that is constantly evolving to keep pace with new technologies and safety concerns. The NEC is updated every 3 years, and it's important to stay up to date on the latest changes to the code. The NEC is a complex document, but it's essential for anyone working with electricity to understand its requirements. Consider taking a course on the NEC or consulting with a qualified electrician to learn more about the code. Remember that electrical safety is everyone's responsibility. By following the NEC and using safe work practices, we can all help to prevent electrical accidents and injuries. Always to energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, call a qualified electrician. Electricity can be dangerous, and it's always best to err on the side of caution. Regarding specific requirements for schools, while the NEC doesn't mandate a particular orientation for the ground lug, it does address specific requirements for electrical safety in educational occupancies. For instance, tamper-resistant receptacles are often required in classrooms and other areas where children may be present. Additionally, the NEC may have specific requirements for emergency lighting, fire alarm systems, and other safety-related electrical equipment in schools. Schools are typically considered commercial occupancies under the NEC, which means they are subject to the requirements for commercial electrical installations. These requirements may include more stringent rules for wiring methods, overcurrent protection, and grounding. Local codes and regulations may also impose additional requirements for electrical installations in schools. It's important to consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes. The NEC addresses the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC classifies hazardous locations into different classes, divisions, and zones, and it specifies the types of electrical equipment that are permitted in each location. Electrical equipment used in hazardous locations must be specially designed and tested to prevent ignition of the flammable substances. The NEC also addresses the installation of electrical equipment in healthcare facilities. Healthcare facilities have unique electrical requirements due to the sensitive nature of the equipment and the vulnerability of patients. The NEC specifies requirements for essential electrical systems, which are designed to provide backup power to critical equipment in the event of a power outage. The NEC also addresses the installation of electrical equipment in swimming pools and spas. Swimming pools and spas pose a significant electrical shock hazard, and the NEC has stringent requirements for grounding, bonding, and ground fault protection. Ground fault circuit interrupters are required for all receptacles within a certain distance of a swimming pool or spa. The NEC also addresses the installation of solar photovoltaic, or PV, systems. Solar PV systems are becoming increasingly common, and the NEC has specific requirements for wiring methods, overcurrent protection, and grounding. The NEC also addresses the installation of wind turbines. Wind turbines are another source of renewable energy, and the NEC has specific requirements for wiring methods, overcurrent protection, and grounding. The NEC is a comprehensive document that covers a wide range of electrical installations. It's important to consult with a qualified electrician for any electrical work to ensure compliance with all applicable codes and safety standards.